Welcome. This question says a sample of gas is trapped in the cylinder of a syringe. It initially has a pressure of 3 Pascal and a volume of 4 cubic meters. Temperature is 127 degrees C. Gas particles cannot be added or removed from the chamber. The chamber volume can be increased or decreased. The sample of the gas can be heated or cooled. And it says show that the sample's volume will be 1.8 cubic meters when its pressure is 10 Pascal and its temperature is 327. So let's visualize it. Is the initial state of the syringe, and we have initial pressure is going to be 3 Pascal, and our initial volume is going to be 4 meters cubed, and our initial temperature is going to equal 127 degrees C. And then we squish it and we play with it, and we end up with a second situation, and our new pressure is going to be equal 10 Pascal, and our new volume is what I want to find out, and our new temperature is equal to 327 degrees C. And what links ideal gases when we can change these temperature, pressure and volume is the gas law. And the gas law says that P1 V1 over T1 is equal to a constant, and so it's equal to, well, P2 V2 over T2. And so we can simply plug into this. So we say 3 because that's our first pressure, and 4 because that's our first volume. And it's tempting to put down 127, but I know enough to know that when you're doing ratios of things, ratios of pressure, ratios of volumes, ratios of temperatures rather than differences, I need to be in Kelvin. So that would be 273. And this equals, if we look at our second part, it's going to be 10 Pascal and V2. And this will be, again, rather than 327, it's going to be 327 plus 273. Because I need to be in Kelvin for this to work. And so if I rearrange, I can say V2 is equal to 3 by 4 times, let's add these two guys up now, 327, 527, 600. It's going to be 600, that goes to the top. And then on the underside we have, well, that's going to be 207, it's going to be 400. And then this 10 will go to the bottom. So V2 will equal 12 times, that's 7,200 over 4,000, which equals lots of zeros cancelling. 4 goes into 7 once. 4 goes into 32 8 times. That's going to be cubic meters. And so there we have it. We have our volume would be 1.8 cubic meters. So it's a pretty standard problem. The only wrinkle is that I threw at you degrees Celsius rather than Kelvin. And when you're doing ratios, when you're multiplying things together, as opposed to looking at differences in temperature, unless you have a really good reason, you need to be in Kelvin. There we have it.